Alright, hello all. So today we're going to look at a new method, which what we call as Gauss-Seidel method. It's a very easy method which uses iterative procedures. Okay, so this method only applies for a 3 times 3 set of equations only. This is very, very important, alright? And if diagonal elements are non-zero, the first equation can be solved for x1, the second for x2, and the third for x3. So for this method, you have to use a formula. So this formula, I wouldn't call this a formula. So this is just, like a11x plus a12x2. So this is x1, sorry. Plus a13x3 equals to b1. So you are trying to solve for x1, x2, and x3. So for this linear equation, so you just bring everything to the right hand side, leaving only x1 at the left hand side. So this one is b1 minus a12 x2 minus a13 x3 divided by a11. So I wouldn't call this a formula because you can definitely rearrange this back from your linear equation into this. But these are the formulas that you will be using for this Gauss-Seidel. So this is for calculation for x1, and this is for calculation for x2, and this is for x3. So this one uses the first equation, and this one uses the second equation, and this one comes from the third equation, the third linear equation, all right? Because you have 3 times 3 set, you have the first, the second, and the third, all right? Okay, so let's look at the procedures. Okay, so in order to do this, you need to have an initial guess. So usually we assume that the initial guesses are all 0, means for all x1, x2, and x3. We can just assume as a starting point, all of these values, they are 0, and then we can move on from there. So this 0 can actually be substituted into the equations above, which can be used to calculate a new value for x1. So let's say you use your first initial to calculate your x1. You just substitute x2 and x3 into this equation, so you will get your x1, your new x1. All right? And then we substitute this new value of x1, the one that you have calculated from this step. You substituted this into the second equation to work out what is x2. Once you have got the new value of x1, you can use that new value inside here, and this one using the initial guess, which is 0, to calculate a new value for x2. And once you got your value, your new value for x2, you can substitute this new value into the third equation here to calculate for x3. x1 still use the one that you have calculated before. So now you got your x3, and you will end up with new values for x1, x2, and x3. So I will explain more in an example later. So the process is repeated to calculate a new estimate for x3. Just now I show you. Then return to the first equation and repeat the entire procedure until our solution converges closely enough to the true values. All right. So this method, you sort of like going on calculating using many iterations. Iteration 1, iteration 2, iteration 3, and then back again, iteration 4, 5, 6, a lot. So when do you know when to stop? Again, we use this concept in which you have to calculate your approximation error, and if your EA is less than your ES, then you will know that you can stop your computation. So it's okay if you cannot get the concept yet. So I will show you how it works and you will see that it's so simple. Okay, all right, so this is an example. Given here a 3 times 3 linear equation. So this is equation 1 and this is equation 2. Well, this is equation 3. All right, so initial values we have to set, and we assume x2, x3, and x1 will be equal to 0. So for the first step, solve each equation for its unknown on the diagonal. So let's solve for x1 first using the formula that I showed you just now. Or if you cannot remember the formula, you can just rearrange this first linear equation by leaving x1 only at the left-hand side and moving the rest of other elements into the other side of the equation. Alright, so you will end up with this for the x1. This is coming from the first equation. And the equation here, the formula to calculate your x2 comes from the second equation. And this formula here, it actually derives from the third linear equation. Okay, so now that you have worked out all your formulas, so this is important. This is the step that you have to do first. You have to come up with the formula to calculate your x1, x2, and x3. And then only you can move on to the calculation. So, iteration number 1. So, let's calculate x1. So, this is 7.85 from here, plus 0.1, x2, and x3 here. You see, they use the initial guess 0, which is this one. So, you will get this answer for x1. And to calculate your x2, just use this formula here. Alright, but this time around, you have x1 and x3. So x1 here, please do not use that initial guess. You need to keep on using the value that you have just calculated, which is this one. This value, substitute into the formula. Since you haven't calculated any new value for x3, so x3 will remain 0 here. Okay, it's still 0, the initial guess. And you will get this value for x2. Now you got all the new values for x1 and x2. You can substitute all these new values into the third equation here, which is because they have x1 and x2, do not again use the initial values. So you substitute this into the third equation to calculate for your x3 and you will get this answer. Alright, so here you can see that the initial values, you only use it for the first and the second equation only, or the second formulas only. Okay, so you have to keep using the values that you have just calculated. Alright, that is for iteration 1. Next is iteration 2. So this is again the formula to calculate your x1, the formula to calculate your x2. This is from the formula to calculate your x3. So now you have all the new values. So this is x2 and x3. The new values from here just now. This is x2 and x3. Use whatever that you have just calculated in for the next calculation. Alright, just substitute those values inside and you will get a new value for x1. So now that you have your second value, second answer, alright, second answer for x1, you can calculate your EA for this iteration. So this EA is the current approximation, which is 2.990557 minus the previous approximation, which comes from here, the previous value of x1, previous, alright, the previous answer. Alright, and put it into this EA formula. divided by the current approximation times 100. So you get 12.5% for EA for the second iteration. Alright, now to calculate for your x2, you have to use, this is from x1 and this is x3. So x1 here, please do not use this or this value, 0 or that. You have to use the one that you have just calculated, which is from here. This value will be substituted here, and this is remain the previous calculated in the previous iteration. So you will get this answer for x2. And again, you can calculate your EA, your current minus your previous divided by your current. This one comes from this previous answer. Alright, next, you get 11.8%. And next is the calculation for your x3. Again, this is from the formula. Oh, this is x1 and this is x2. And you have to use the previously calculated answers. So this is from here and this one comes from here. Okay, so you will get this answer and you can calculate the EA, which is 7.6%. Alright, so you can move on to the third iteration, to the fourth iteration, to the fifth iteration. So provided that you have to calculate your EA after each calculation of the x, because you need to know when to stop your calculation, how many iterations that you have to do. So it all depends on the EA. So let's say the problem gives you the value of ES, which is 10%. All right, 10%. Okay, let's look at the first calculation of EA here. It's 12.5%, which is still more than the ES. And this one, which is 11.8%, it is more than the ES. And for the third one, it is 7.6%, which is less than the ES. So there is only one calculation which is less than the ES. The rest, they are still more. So do you think you need to continue your iteration? The answer is yes. You need to continue your iteration until all EAs fall below ES. What I mean by this is all EA for x1, x2, and x3. 3 of them has to be below the ES value. Then only you can stop your iteration. If only one of them is more than the ES, you still need to continue. So this is crucial, okay? Some students, they really confused, right? Sorry. They really confused about this concept. They thought that, okay, I've got one EA which is less than the ES, so I can stop. No, you will get the wrong answer. You have to continue your calculation. You have to do additional iteration until you finally calculate your EA, all of your EA for all x1, x2, and x3, and you will get it less than ES. Then only you stop your computation. Alright? So what I want you to do is, I want you to try this on your own. This is very simple. Use Gauss-Seidel method to solve the system to ES of 5%. So please try this and we will discuss the answer in our next meeting. Thank you.